Okay, 13.3. 50 students, 30 females, 20 males. Math 101 class at Tasmania State University. Professor chooses a sample of 10 students from the class as follows: 5 from among the females, 5 among the males. Does every student in the class have an equal likelihood of being selected for the sample? Does every student have an equal likelihood of being selected for the sample? You can tell I'm saying no. There's a higher chance of selecting a male student than a female. Why? How am I coming up with that? You see what's going on up there? There's 30 females in the class. There's 20 males. And five from each. Choose 5 and choose 5. So they're choosing 5 males and 5 females. So that means that if you're a female, what's the chance you're going to get selected? What's the probability? How would we figure that out? If you're a female, there's only 5 out of 30 being selected. Whereas if you're a male, there's 5 out of 20. That's higher. Right? It's a better chance you're going to get selected for the males. 5 out of 20 males are being selected, whereas only 5 out of 30 females are selected, right? There's more females, so if you're only selecting 5, there's a less probability that if you're a female that you're going to be selected. Question B, does every set of 10 students in the class have an equal likelihood of being selected? No. For example, a group of 10 females has no chance of being selected, right? So we're just proving that this is not truly random, this way of selecting things. We're into this random thing, and we're showing this isn't purely random or simple random, right? That's just another way of displaying that. I'll leave that. There's not, that's a good question. Okay. Whether the given value is a sample statistic or a population parameter. 37 seniors at college, it found that 50% own a vehicle. That's a population parameter because the value is a numerical measurement describing a characteristic of the population. What's the difference between a sample statistic and a population parameter? Remember, a sample is a small group, and it is a statistic. I'm not saying that very clearly. A statistic is from a sample, which is a small group, whereas a population is the whole group, right? So it's the difference between surveying before an election, asking people, are you going to vote for Joe Blow? And then the actual results in November, when we see what the whole nation did, right? That's population, when the whole nation votes. It's just a sample and a survey when they do a poll beforehand. Okay, so this is a population parameter because this is all the seniors at the college. This is the whole college. It's not just, hey, we asked 50 seniors and hey, 33 of them owned vehicles, so this is what we think. That would be a sample on that. All right, I know these questions are kind of funny. Let's, okay, choose the most appropriate concept for the statement. Association is not causation, sampling variability, selection bias, placebo effect. One pollster waited outside her local town hall and asked people walking by which party they had voted for. She was surprised to see the Democrat win when her results showed a landslide Republican win. That's selection bias. What are we talking about? How is that selection bias? A pollster waited outside town hall and asked people walking by which party they had voted. So right after you understand, like, this is one of the ways they poll. Right, during election time, they'll wait till people get done voting, and as they come out, they'll say, "Who'd you vote for?" And they'll write it down, and then they keep a survey, and then they report it to the news stations, and the news stations say, "Here's what's exit polls." Right, exit polls. You heard that? they're exiting. They're on their way out. They've just voted. They say, who'd you vote for? That's an exit poll. Well, do you know those can be faulty? Those can have, and history has proven that. Remember the super close year? What was it? Al Gore and George Bush with Florida going red, blue, red, blue, red, blue, right? Which one would it be? Florida determined the national vote, right? Remember that year? Maybe you were too young. How many years ago was that? I don't know. Anyway, so that year it was super close. Hanging chads and all that. Maybe it's history for you guys now. What's that?
Wasn't that 2002?
I don't remember. Something like that. Yeah, something like that. Is that far ago? Yeah, it was a while ago. Getting to be one of those old guys now. I think, yeah, wow, that was a while ago. Yeah. Anyway, yeah, that sounds about right. I think so. Anyway, that year, it was exit polls were done. They were asking the same kind of thing. When people are coming out, who you can vote for, you can vote for. It turned out that, and I can't remember which way it went, but it was systematic. That's what's kind of interesting about it. People that voted for one candidate or the other, I think it was people that voted for George Bush. Was that right? I can't remember. I'm sort of guessing. It's in the book somewhere. I can't find. I don't want to take time to try to find it. So I'm sort of guessing. You can type it into Google, probably find it. I think it's people that were voting for George Bush didn't want to talk about it as much as people that were voting for Al Gore. I think it was that way. It might be reversed. Anyway, so in other words, people were coming out of the polls, and they would ask them, "Who'd you vote for?" If they voted for George Bush, they tended to be not as interested. They might say, I don't want to talk about it, and walk by, more likely than people who voted for Al Gore. And it might have been reversed, I don't remember. But one candidate than the other were, for whatever reason, were more likely to talk about it. And so they got false results. People that did vote for one of the candidates were telling everybody, yeah, I voted. And the people that voted for the other were a little more secretive about it, less interested in talking about it. And they found that it was a big result that for the whole polling world, they realized they got to be careful about polling, because you realize by asking them in a certain way, you're getting a certain, see how easy it is to mess up in polling? What you've got to do is you've got to ask them in different ways. You can't just do all exit polls. You can't just do it all at one site. You've got to ask them in different ways, in different places. You've got to do something to keep it random. Even something as silly as, I want you to tell me who you voted for. Some people that vote for a candidate, and it's not just random, it's systematic. People who voted for one candidate tended to not want to talk about it a lot more than the other candidate. I don't remember the details of the time, but they got way off I remember the polls that year were just way off, some of the exit polls, and this is what happened. Remember that whole thing? You don't remember the whole thing. Remember they swore, they gave Florida to Gore. They said Florida's got Gore, and Gore wins. And then there was like, oh, well, we're not sure now. And then they kind of backed up, right? Because they were getting exit poll information that was wrong based on this kind of thing. So that's a selection bias. They were getting biased results based on the way they were getting their information. So this is tricky. Okay, so the way the questions and mini surveys are phrased can itself be a source of bias. We're talking about biases, right? Okay, so here's the question. Do you oppose the present state flag that contains the Confederate symbol, a symbol of past slavery in the South, and a flag supported by extremist groups? What do you think about that question? They're trying to find out if people support the flag the way it's been done or not. And they're asking them, do you oppose the present state flag that has a Confederate symbol, a symbol of past slavery in the South, and a flag supported by extremist groups? Explain why this is an example of a leading question. Right? You can sense it, as you read it. This is a leading question right there, because it provides negative information right in there. Right? Who's going to want to say, yeah, I support it. I love those extremist groups and that slavery stuff. I'm all for it. Put me down. Brett Herron, please. Yeah, write it in big bold letters. Right? I mean, even if you do have some crazy view and so you're in favor of that, you don't want to hide about it, right? When they're presenting it that way. So if they want the truth, if they want to make people think something, okay, then give a speech or whatever. But if you really want to know the truth about what people currently think, don't ask a question like that. You're not going to get the truth, right? You're going to get people embarrassed to say. They're going to walk away and think, yeah, I support it. I'm not telling that guy, though, right? That's what they're going to do, right? You're not going to get the truth. So you got to be careful in your questions if you want the truth to not lead like that. All right, next question. What is a better way? Yeah, do you favor or oppose the current state flag that has the Confederate symbol? Just straight. No negative information, no positive information, just straight like that without supporting information. Okay. Give it to you. Let's do a question from it, see how you're doing. In fact, why don't you just try number 1 there? See what you can do. So you've been through the material now, but it's more tricky than that. So try number 1. As part of a statistics project, 6th grade teacher brings to class a container with 300 red marbles, 500 white marbles. Student randomly draws 40. Of the 40 drawn, 16 are red. All right, give it a try. So let me give you a minute. Try to do questions 1, 2, and 3 even, and then I'll answer them. Because this chapter, it's so easy to fool yourself as to how much you really know this material. So we really need to practice. Those homework questions are kind of so-so. They're not the most helpful. So let's spend some time on the practice exam so we can get it down here. So try number 1 there. 2. Try number 1, 2, and 3. I'll give you a minute. All right. The data collection method. Well, on multiple choice, sometimes it's good to read them all. What are they doing? Is it a survey? Maybe, I don't know. What's a survey? Is it a clinical study? No. Let's start eliminating things. Clinical is medical. That's the medical kind where you do like a drug or a surgery or something, right? That's a clinical study. This is not clinical. There's nothing like that going on. Is it a controlled study? No. There's no control group. There's no group that got a fake pill or something, right? There's none of that going on here. Is it a census? Well, you got to know what a census is. No is the answer. No. A census is the whole population, right? Do you understand the difference? Whereas a sample is from a small group. So census is the whole population. So when they do a census of the nation, they count all the people in the nation. When they do polling, they just sample a small group, right? The actual election in November, that would be a census. That's what does the whole nation think? That's the actual census. Censuses are big deals. You can't do those easily at all. That's everybody's vote, right? That's a census. This is not a census. They didn't count all the marbles, did they? They didn't dump out the whole jar and count them all. They only grabbed 40 and 16 were red. That's all they did. They took a sample. They did so it is survey. They took a survey. Survey just means a small little group. It's like a sample. That's what they did. Does that make sense? Let's try number 2. So remember what they're trying to be clear. Part of the trick on these questions is the reading. Look what they want to do. To figure out, those words matter. That tells you why they're doing what they're doing. To figure out how many marbles in the container are red without actually counting them all. So that's why it's not a census. They didn't count them all. They didn't dump out the whole thing. Now we know, because we've been told 300 are red, 500 are white. But they don't know. And they're taking a little survey, a little sample. They just took out 40, 16 were red. Right? That's like grabbing fish. Grabbing a little bit of fish, how many have tags? Asking some people, who are you going to vote for? Right? To get an idea of the whole. Right? A sample is to tell you about the whole. So on number 2, what's the target population? Think about that for a minute. What's the target population? The target's what you're aiming at, right? Like the archer. What are they aiming at on that question? What are they aiming at? What's their goal? What do they want to know? So target is your goal. So target is what we desire to know. What do they desire to know? Why are they doing what? Why are they grabbing the 40 marbles and 16 in a row? Why? Why are they doing that? What does it say? To figure out how many marbles are red out of all the marbles. So their target, is their target to know something about all 800 marbles? Yes, absolutely. They want to know, of those 800, how many are red, don't they? Is their target the 16? No, the 16 is just was just the red ones. The 40 is just what they grabbed. The 300 is just part of the whole. They want to know, their aim is to know about all 800 marbles in the container, how many of them are red. Now you might think, well, no, they just want to know about the 300. Well, they don't know that. They don't go in thinking, I just want to know about 300 marbles. No, they don't know how many red. They go in thinking, I want to know about this whole container of 800 marbles. I want to know how many of them are red. It's A again. Does that make sense? See, it's how it's a little subtle. It fools people a lot on that. I'll try number 3, and we'll wrap up with number 3. The sample consists of So what's the sample? Yeah, it's A again. It's the 40. The sample's the 40. Is that good? All right, we will